Great! We've made excellent progress so far. Put yourself in the shoes of a BI analyst. Imagine you have to work with a Python module that, when fed with a specific type of data, delivers the probability that a certain individual will be absent from work for more than 3 hours. Technically, it is possible to save this Jupyter output as a CSV file. Then you could load, analyze, and visualize the data in Tableau. However, to solve our business exercise, we will follow a different approach. In fact, one of our primary goals is to take advantage of the integration of SQL, Python, and Tableau. So, it is time we moved on and started using SQL. I'd like to mention that had we installed the TabPy server, which is Tableau's server component for integration with Python, our analysis would have been centered around using Tableau mainly. The SQL database could have been used as a storage place, and Python for developing new functions. Installing TabPy, however, is not the most straightforward technical operation you'll ever come across. CSV files can be used as a substitute for transferring data as well, and that's what we'll do. This would allow us to solve our exercise while preserving the same logic of exchanging information between Python, SQL, and Tableau, as opposed to if we had used TabPy. So, as we promised many lectures ago, we will store the data on a separate software. For this purpose, we will code in one of the most popular versions of SQL, MySQL. And the tool that will give us the space to apply this code will be MySQL Workbench, a global leading software for working with relational databases. If you still have not installed Workbench on your computer, please pause here and refer to the note provided after this lesson. For any problems you encounter along the way, feel free to contact us in the course Q&A section or check previous discussions that have taken place there. Otherwise, I will assume you have installed Workbench successfully and will now continue with the exercise. What should we do to benefit from a successful integration between the Jupyter Notebook app and MySQL Workbench? There are a few technical steps to complete beforehand. First, we should start MySQL Workbench. Let's do this. When the application is loaded, select an existing connection to the MySQL server. Currently, I only have one set up. I'll click on it. Then, think of a username and password you need to start this connection. In my case, these are native user and 365 pass, respectively. We are in. Now, we are ready to execute some code. What code? We won't be able to send any data from Jupyter to MySQL Workbench until we have created a connection to a specific database. Therefore, we'll need to write a query that will create such a connection for us. Before doing that, please note the following. To complete this section of the course, you won't have to worry about more sophisticated parts of SQL code. You won't have to understand them in depth. Such a task is beyond the scope of this course. Just remember that MySQL is a language with a highly intuitive syntax. So, hopefully you will be able to follow along without facing major problems. Let's take a step back and explain why we decided to include SQL in the solution of the business exercise. Being able to work with SQL gives BI analysts more control over their work. So, in the next few videos, please focus on the process of integration rather than on the details in the code you see. If you want to master more sophisticated code beyond what you see here, please check out our specialized SQL course. All right, let's go back to coding. In a new tab in MySQL Workbench, we will run a couple of statements. First, what's the idea here? To create a database. We should give it a name related to the role it'll have in our exercise. Given that this database will contain the predicted output values obtained with our logistic regression analysis, we'll call it Predicted Outputs. A standard SQL practice is to first drop a database with an identical name in case one already exists. Thus, we can remove any database with a duplicate name. To run the query that'll actually drop predicted outputs for us, we'll need to click on it and then press this lightning symbol with a cursor up here. Another way to do the same thing would be to click somewhere over the query. Hold the Control button and then press Enter. Whichever of the two techniques we choose, we will receive a message telling us such a database does not currently exist. This means we can go ahead and create our database. We'll do this with the help of the next query. Click on it, hold Control, press Enter, and congratulations! The predicted outputs database has been created. However, please bear in mind we have plenty to do in MySQL. So far, we've only created the structure of our database. In other words, it is not ready to be used right now. To achieve the latter, we must execute use predicted outputs. Done! At this moment, we can attach to the predicted outputs database from Python. And that's exactly what we'll do in our next lesson. See you there!